Hey everyone, I'm just going to show you a couple quick examples of how we can take some shortcuts on our dihybrid crosses. So let's look at this example first, where we've got yellow pea seeds that are dominant to green and round pea pods that are dominant to wrinkled peas. And so if we have a heterozygous yellow and round plant, heterozygous means that we're going to have one dominant and one recessive for both the yellow, and it says heterozygous for round as well. So that's going to be our genotype of that parent. And then our green and wrinkled plant is going to be small y, because that's the only way to have green, and wrinkled is little r. So those are our genotypes for our parents. Now, if we were completing a large Punnett square for this, again, we're going to FOIL this parent, so big Y, big R, first terms, outside terms, inside terms, little y and big R, and our last terms, which are little y and little r. We're saying that there's a 25% chance for each of those gametes to be produced in that parent pea plant. And in the other plant, we're going to do the same thing, and if we FOIL first terms, outside terms, inside terms, last terms, what we end up with is little y, little r, little y, little r, little y, little r, little y, little r. And so we could go ahead and do the entire Punnett square, but it's kind of a waste of time because all four alleles from this parent are all exactly the same. So I could do the whole thing, but I'm not going to. I'm going to just eliminate these guys right here. We're going to take out that one. We're going to take out this one. We're going to take out this one. Why? Because all three of these are exactly the same. All four of them are the same. There's no reason to do all four. We're just going to do one of those columns. And so we end up with big Y, big R, little r, big Y, little r, little y, little y, big R, little r, and little y, little r, little r. So what we have here is we have a 1 to 1 to 1 to 1 ratio. We've got one that is yellow and round. This one's yellow and round. We have one that is yellow and wrinkled. We have one that is green and round. And we have one that is green and wrinkled. So essentially we have a 1 to 1 to 1 to 1 ratio. If we would have done the whole Punnett square, we would have ended up with a 4 to 4 to 4 to 4 ratio, which we would have had to simplify anyway. So there's no sense in doing the whole Punnett square when you have repeating gametes. Okay? So that's one shortcut. Don't do the whole Punnett square if you don't need to. If you have repeating gametes, only do each repeating gamete once. The second shortcut that I'm going to show you, we'll use a blood type example. And so if we have these two parents, of course, this would be a type AB positive parent because they're positive. They have the R for the rhesus antigen, whereas this person would be type O because they have the two little i's, and they are also positive because they have the big R. So we have an AB positive parent and an O positive parent. And if I want to know what's the probability that they're going to have a B negative child, you could do the large Punnett square and FOIL again, big I, IAR, IA little r, so you'd have something like this. And then the inside terms, IB big R and IB little r. So you could do that, and you do the same for this parent, little I big R, little I little r, little I big R, little I little r, right? So you could do that. And you could use the shortcut that we used on the last one, where I wouldn't do this one and I wouldn't do this one because they are exactly the same. And so that's one little trick, one little shortcut you could use. But what I could also do is I could also do two separate Punnett squares. I could do one for the ABO blood typing, like this. Okay. So there's my two parents, and I could figure out what's the probability of producing a child with type B blood. Okay. And the probability of producing a child with type B blood is 1/2. And then I could also do a Punnett square for my rhesus antigen. Right? This parent is big R, little r. This parent's also big R, little r. And so for my rhesus antigen, the probability of being negative is just right here. It's just 1/4. So the probability of being type B is 1/2. The probability of being rhesus negative is 1/4. And if we multiply those two probabilities together, we get 1 out of 8, which is exactly what you would find if you did this Punnett square as well. Let's see if we can see which one is going to be B negative. That's going to be This guy right here is going to be our B negative, which is going to be 1 out of 8. If you would have done the whole Punnett square, of course, it would have been 2 out of 16, which we would have simplified to 1 out of 8. Anyway, so that's it. A couple of shortcuts for your dihybrid crosses.